Hey, can everyone see my screen okay and hear me okay? Okay, perfect. So my name is Saanvi Vavilala. I am currently a rising senior at the University of Texas at Austin. I'm majoring in cell and molecular biology, and I plan to get a PhD in a similar field and then enter the biotech industry doing lab research. So, my past experience with research at UT Austin consisted of studying a certain mutation and its effects on alternative splicing in cell culture. And I really enjoyed my research there. However, I felt I wanted some more experience with actually studying disease and how that can be applied in research. And that's what brought me to the HuBMAP program. And I'm very excited to have been able to work on translational research these past couple of months here at the Pay Lab, which is part of the University of Pennsylvania and also the Children's Hospital of Philadelphia. So PayLab is actually part of a tissue mapping center here, and it's part of a pipeline where we do sample pre-processing as well as certain multiomics assays such as snRNA attack sequencing for epigenetics. And then the samples that we pre-process are also sent off to a variety of different labs to gain more information relating to genomics, epigenomics, transcriptomics, proteomics, and metabolomics, which then overall is able to contribute a wide variety of different types of data for HuBMAP and its databases. So during my time here, I've been lucky enough to be a part of a couple different donor heart collections. So I was able to witness the actual human hearts with my own eyes, and that was a very interesting and unique experience for me, especially as someone who doesn't plan to go into medicine. I never thought I would have the chance to see a real human organ right in front of me and get the chance to study them in such depth. So. The actual condition that I've been studying this summer is called left ventricular hypertrophy, or LVH. And it's essentially occurs when the left ventricle of the heart thickens to pump more blood to compensate for a lower blood flow. And in this condition, when the heart grows, as in when the heart experiences hypertrophy, the cells don't multiply, but in fact, each cell individually enlarges. And this condition affects 10 to 20% of adults, but for those with hypertension, it can affect up to 40% of those. So on the right here in the figure, the top heart is a perinatal heart. So that's why there's a lot more cells. It's normal for early stages of life. The middle heart is a regular healthy adult heart, and the histopathology image shows a healthy amount of cells at a healthy size. And then the bottom image shows a adult hypertrophic heart. And you can kind of see in the picture on the right that there's each cell is a lot larger and the heart walls are a lot thicker. So for my personal research project, I focused on using immunofluorescence imaging to identify hypertrophy in cardiomyocytes across different donor heart samples. At the Pay Lab, we've already collected mass data on the overall hearts, but in order to confirm if hypertrophy is truly present, we needed to collect data at the cellular level. And here's a little bit of metadata about all the different donor hearts we collected. So these hearts have been collected from the greater Philadelphia area over the course of the past 3 years, and we essentially exclude hearts over the age of 70 to avoid age-related deterioration and other variables like that. There, the ethnicity is um, there's people, the hearts can come from people who are white, black, Hispanic, and there's an even split between male and female. Overall, we have 22 healthy hearts and then 7 hearts that display mild hypertrophy. So the type of staining I chose to use is called WGA immunostaining, and this targets the polysaccharides in the outer membranes of each cell and gives us a good view of the shape of each cell, and that allows me to calculate the exact area. In this picture, you can see I've highlighted certain cells, and you can tell that the staining is able to provide a clear outline of each membrane. And throughout this whole process, I learned a lot of different things about imaging. One of the most important things is I learned how to differentiate between different cell types within the tissue. So on the lower side, you can see like these rectangular cells are cardiomyocytes, whereas certain other types are not cardiomyocytes. They might be fibroblasts or other types of immune cells that are also present in the tissue. In addition to telling the difference between different types of cells, I've also learned how to differentiate between the different ways the sections can be cut. So sometimes the sections are cut transversely and sometimes they're cut on the longitudinal way. When they're cut in the short way, we aren't able to see the exact shape, but when they're cut the long way, I'm able to get a better idea of the area and shape of each cell. Here are some representative images of a healthy versus a hypertrophic heart, and these are both at 20x magnification, and you can see the one on the left. Visually, you can tell that the cells are smaller than the ones on the right. And that just goes to show that there is, you can observe the hypertrophy on a cellular level. This is a quantitative visualization of the data comparing one heart that is healthy and then one heart that is has LVH. And the p-value shows that there is a significant difference between the two hearts, and the one that has hypertrophy, the overall cardiomyocytes are larger on average. So in the future, I plan to complete my analysis for all of the different 29 hearts. So since each image, I cannot analyze every single cell just due to imaging and the fact that sometimes the bounds aren't as clear, I plan to count cells from as many images and fields as possible per heart, and then use all of that data to finalize our classification of is the heart healthy or does the heart have LVH. So in addition to my personal project, I've also had a lot of opportunities to gain different types of experience at the Pay Lab. Through HuBMAP and Fusion, I've gained some coding experience, and then I've also gained proficiency with techniques such as Western blotting, qPCR, genotyping using PCR and gel electrophoresis, immunoprecipitation. And my favorite part about this lab is how welcoming the community is and how they really made me feel like part of the family here at PayLab. So, in conclusion, I think these past 9 weeks here have been very transformative for me. I've not only learned a wide variety of new lab techniques, but I've also learned more about what it means to be a scientist and what this career path has to offer. So, I'd like to extend a big thank you to HuBMAP and NIH for making this program possible. Thank you to my PI, Dr. Pei, and thank you to my mentors. Um, for always being there for me, answering all my questions because I know I've had a lot of them. Thank you.
Good job. Does anyone have any questions for her?
I have a quick question.
Yeah, of course.
Congratulations on your presentation. And I grew up in Austin, by the way, so I didn't go to UT,
Oh,
but
wow.
very, yeah, impressive. Hook 'em horns. I
Yes.
had a question about LVH. Is it something that
Mhm.
is um, related to low blood flow causatively, or can it be congenital too from birth?
So, from my understanding, it's more of a condition, like you said, that arises from certain pre-existing conditions. So, if somebody has low blood pressure, like hypertension, certain conditions like that will then lead to LVH.
Okay, got it.
Do we have any collaborators that want to comment on that and verify? No. All right, no worries. Does anyone else have any questions?
Great
Okay.
work, Saanvi. Really nice images. If you had
Thank you.
more time, what else would you like to have done? You already did a lot, but what would you love to do more?
Yes, definitely. I felt the time constraint on this 10-week program. I think if I had more time, I would have loved to take even more pictures of each heart because due to the time constraints, I had to more focus on certain areas and focus on making the most of the time that I had. But given more time, I think I would analyze every sample in detail completely.
Yep, that's the one thing with research is you never have enough time, no matter how hard you try, nor does research ever
Yep,
match the deadline you want it to. I'm sure all of our
exactly.
collaborators know, especially with grant season coming up, it's go, 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 go. But that's a wonderful presentation. Thank you so much.